Bismillah ar-Rahman ar-Rahim. We'll continue doing this section 3.5 for the implicit differentiation, logarithmic differentiation also. Now we'll talk about if I have function to the power of function. So before that, let us review the cases, the 4 cases if I have something to the power something, where f can be constant or variable. And the same thing for g, can be constant or variable or function. Non-constant function, constant or non-constant. Okay, so if both of them, f and g, are constant, so you have constant to the power of constant, so all of this is constant, so the derivative is 0. Okay, now if I have function, f is non-constant and g is a constant, so you have function to the power n, variable base and constant exponent. The exponent is constant. What will be the derivative? It will be n f of x to the power n minus 1 f prime of x. The next case where f is a constant, this one is a constant, this is a constant, but this is a variable exponent. So I have a number to the power g of x, so it will be b to the power g of x times ln b times g prime of x. That will be the derivative. The last case, which is the main case, if I have function to the power function, variable base and variable exponents. What I need to do, I need to do logarithmic differentiation and then use implicit differentiation. Let us do an example. Y equal x to the power square root of x. So I have function to the power function. None is constant. So f and g are non-constant functions, which is case 4, which is this case. The other 3 cases we did before. Huh? Okay. So what I will do, logarithmic differentiation, take ln. You get what? Ln y equal ln x to the power square root of x, which is square root of x times ln x. Now differentiate with respect to x. We get what here? I have y prime over y. Here I have product of 2 functions. Derivative of the first times the second plus the first derivative of the second. Which means that y prime will be y times this, which is ln x over 2 root x. This one is what? 1 over root x. Huh? Yeah, x to the power half over x to the power 1. I have 1 over root x to the power minus half. Which is I can make it. I know y. Y is x to the power square root of x. This is, I have 2 plus ln x over 2 root x. That will be my answer. Yeah, which is ln x. Wait a minute. Ln x over 2 root x plus 1 over root x. Yes. Another problem. Y equal x to the power 2x. Take ln. I have ln y equal ln x to the power 2x, which is 2x ln x. Now differentiate with respect to x. We get what? Y prime over y, derivative of the first 2 ln x plus 2x, derivative of ln x, which is 1 over x. So that is what? 2 ln x plus 2. Yeah, x with x concept. So y prime will be y times this, which is x to the power 2x times this. Yeah. More problems. Number 1. Take ln. All of these 3 cases, take ln. Huh? I have what? Ln y equal x ln x. Let me do it quickly. Differentiate with respect to x. I have y prime over y equal what? Product of two functions. I have ln x times 1 over x plus 1. So y prime will be 1 plus, will be y, which is x to the power x, 1 plus ln x. 2. Take ln of both sides. Ln y will be what? Yeah, ln x to the power ln x. So that gives me ln x, ln x. Differentiate with respect to x. To get what? Y prime over y. It will be what? Ln x over x plus ln x over x, which is 2 ln x over x. So y prime will be y times 2 ln x over x. Third one, I have ln y equal x ln 1 plus e to the power x. Differentiate with respect to x. Get what? Y prime over y equal product of two functions plus x, 1 plus e to the power x, derivative of this, which is e to the power x. So y prime will be y times ln 1 plus ax plus x ax over 1 plus ax. Yeah, that's it. 4. Take ln of both sides. Same thing, take ln. That will be ln y equal what? X ln 1 plus ln x. Differentiate with respect to y. Differentiate with respect to x, sorry. With respect to x. You have x ln of this. So I have y prime over y, product of two functions, ln 1 plus ln x plus x times. What's the derivative of this? We have 1 plus ln x times the derivative of this, which is 1 over x. So I have y prime will be y times ln 1 plus ln x plus this is cancelled, x with x, 1 over 1 plus ln x. 5. Take ln of both sides. I have ln y. This is a product of functions, huh? We don't have something to the both sides. So the same thing. Take ln of logarithmic differentiation. Ln y equals what? I have ln x to the power half plus ln e to the power x square plus ln x square plus 1 to the power 10. And that equal to half ln x plus x square. Ln e is 1, huh? Plus 10 ln x square plus 1. Now differentiate with respect to x. To get what? Y prime over y equals what? Half 1 over x plus 2x plus 10. I have x squared, x squared plus 1, and this is 2x. So y prime will be y, which is all of this. I will not write it. 1 over 2x plus 2x plus 20x over x squared plus 1. That's it. Now, this example 7. I need to find the equation with the tangent line. So I need the slope will be y prime at 1. So I need to find the derivative. To find the derivative, I need logarithmic differentiation. So take ln. I have y. Take ln. You get what? Ln y x 1 plus x. Okay, differentiate with respect to x. I get what? Y prime over y. Sorry. Y prime over y. This is product of two functions. I need to squeeze it. Then 1 plus x over 1 plus x. The derivative of this is 1, so nothing to worry about. Okay, so y prime. Now substitute. I have the point. X equal 1 and y equal 2. To get y prime equal to y equal to ln 2 plus 1 over 2. Yeah, I put x equal 1. So I have what? Oh, ln 2 plus 1. In other words, 1 plus ln 4. That's the slope of the tangent, m tangent. So what is the equation? Y minus 2 equal the slope x minus 1. You can simplify it. So this is the equation. Let me go to the old exam questions. Yeah, what we have, let me write, I think is this, ax square root of x. And they want to find y prime 1 over a equals what? So to do this, I need to take ln. Take ln. To get what? Ln y equal square root of x ln ax. Okay. Differentiate with respect to x. I have y prime over y 1 over 2 root x ln ax plus root x times. This is ax derivative of this, which is, so this is cancelled. So y prime will be y times this. Plus 1 over root x. Okay, I can substitute. Now, if x equal 1 over e, what will be y? Y will be e times 1 over e to the power square root of e. This is 1 to the power square root, 1 to the power anything, that will be 1. So y equal 1. So plug the numbers here. So that will be, so that means y prime at x equal 1, or y prime at 1 over e will be y, which is 1 times what? Ln e times 1 over e over 2 root 1 over e plus 1 over 1 over root e. Yeah, root 1 over e. This is ln 1, which is 0. So I have 0 plus this one is 1 over 1 over root e. So the answer is root e, and that is the answer. Okay, more problems. Now we need to find y prime. Take, I think we did this before, 2x to the power 4x. Okay, take ln of both sides. Take ln. So I have ln y equal 4x ln 2x. Differentiate with respect to x. You get what? Y prime over y equal 4 ln 2x plus 4x times, this is 2x, derivative of this, which is 2. So y prime will be y times 4 ln 2x, this x with x, 2 plus 4. So that will be y. I can take 4 also common factor. So I have 4y ln 2x plus 1, which is this one, or 1 plus ln 2x. Who cares? y equal ln x to the power cosine x. Yeah, be careful with the calculation. I need y. No, that's good. So take ln. What you have? Ln y will be cosine x. Let me do it in a step. Ln of ln x to the power cosine x. So that will be cosine x ln of ln x. Now differentiate with respect to x. To get what? Y prime over y equal what? Minus sine x ln of ln x plus cosine x times. Here I have ln x, derivative of this, which is 1 over x. So y prime will be y times minus sine x ln x plus cosine x over x ln x, which is this. Yeah. 2x plus 1 to the power secant. Now I need to find the derivative at 0. Just substitute at the end. Okay. So take ln. I have ln y equals secant x ln 1 ln 2x plus 1. Differentiate with respect to x. I have y prime over y equals secant tan ln 2x plus 1 minus or plus secant x. Here I have 2x plus 1. This is 2. Yeah. Derivative of this, which is 1 over 2x plus 1. Derivative of 2x plus 1, which is 2. So y prime will be y times all of this. Okay. Now if x equals 0, y will be what? Y will be 2 times 0 plus 1, which is 1 to the power secant 0, which is 1. So it will be 1. So y prime will be y prime at x equals 0. Let me say y prime at 0. That will be 1. Secant 0, tan 0 is 0, so that's 0. Also ln 1 is 0. Plus 2, secant 0 is 1 over 1. So the answer is 2. That will be the answer. Sine pi x over 2 over ln x. Who cares? Okay. Take ln. So I have ln f of x equal ln. Let me do it. When you feel there is a checkpoint, we'll do it steps. So this is, we'll go into front. Ln x, ln sine by x over 2. Differentiate with respect to x. So I have f prime of x over f of x equals, here I have what? Ln of sine by x over 2 over x. Derivative of this is 1 over x times this, plus ln x times, I have sine by x over 2, and that will be cosine by x over 2 times derivative of by x over 2, which is by over 2. Now substitute at 1, f prime at 1. F prime at x will be f of x times what? Ln sine by x over 2 over x plus ln x times by over 2 cosine by x over 2 over sine by x over 2. Now, if f prime, f at 1, I need f at 1. F at 1 will be sine pi over 2, which is 1, ln 1, 0. So that will be. So f prime at 1, f at 1, which is 1, ln of sine pi over 2 over 1 plus ln 1, which is 0, pi over 2 cosine pi over 2, which is 0, over sine pi over 2. So I'm getting what? 1, 0 plus 0, which is 0. That will be that. Yeah, calculation. Huh? That's the. Okay, let me continue. Take ln. Oh, not right. Take ln. Differentiate with respect to x. Let me do it quickly. So I have ln y equal ln x, ln of all of this. Differentiate. I have y prime over y. That will be all of this over x plus ln x times. This is in the denominator. Derivative of this, which is cosine x minus 1 plus pi over 2. Derivative of this, which is 1. So no need to worry about it. So what I need to do, first I need to find y at 1. Y at 1, it will be 1 minus 1, 0, sine pi over 2, which is 1 to the power 0, which is 1. So y prime at 1 will be y at 1, which is 1, times. Now we need to do this. Then 1 minus 1, 0, sine pi over 2, ln 1 over 1, plus ln 1 cosine pi over 2 over sine pi over 2. Yeah, like before, that will be 0 plus 0, which is 0. So this is the answer. 1 plus square root of x to the power x. Take ln. I have ln y. Let me do it quickly. That will be x ln 1 plus square root of x. Differentiate respect to x. Y prime will be ln 1 plus root x plus x times 1 plus root x, 1 over 2 root x. Now, if x equal 1, what will be y? Y will be 1 plus 1 to the power 1, y equal 2. So here I have y prime will be 2 times ln 1 plus 1, ln 2. I'm writing x equal 1, huh? Y prime, sorry. So y prime at 1, huh? It will be y, which is, y will be here, so y times, which is 2, ln 1 plus 2 plus x equal 1, 1 over 2 over 2. So that will be 2 ln 2. This is 1 over 4 times 2 plus half. So that will be half plus ln 4, because this will go as a whole. So this is the answer. Square root of x to the power x, where y prime at 2. Okay, let us see what will happen. Take ln y, x, ln square root of x. Differentiate y prime over y will be ln square root of x plus x times the square root of x, here 1 over 2 root x. Yeah. I think I simplified. Y prime will be y times this. Here I have what? This is 1 over 2x plus 1 over 2 times x. Okay, so what will be y at 2? It will be root 2 to the power 2, which is 2. So y prime equal 2 times what? Ln root 2 plus half. 2 times half, this is 1, plus 2 ln root 2. Root 2, which I can write it 2 to the power half. So that will be 1 plus half times 2, which is 1 plus ln 2. And that will be the answer. This is y prime at 1, sorry. Yeah, this is y prime at 1, which is the question. Well, at 2, sorry. At 2, not 1. Yeah, substitute everything x equal to. Okay. Take ln of both sides. And I need to find the derivative at e. So I have ln y, ln x. Differentiate. Y prime over y equal to x ln x plus x squared times, here I have ln x, and here I have 1 over x. Now, y at a will be ln a to the power a squared, which is 1 to the power a squared, which is 1. So y prime, let me do it one step, y prime at a will be y at a, which is 1, times here I have 2a ln a. Plus, this is half x plus a over ln a. Ln a is 1, ln 1 is 0, so I have 0. Ln a is 1 plus a, which is a. That will be the answer. If I cosine x to the power ln cosine x, then y prime, take ln of both sides. Ln y will be ln cosine x, ln sine x. Differentiate with respect to x. So I have y prime over y equal. What is this? This is cosine x minus sine x times the other function plus ln of cosine x. Here I have what? Sine x. Here I have cosine x. So y prime will be y times, this is what? Minus tan x ln sine x plus cotan x ln cosine x. And what is y? Y sine x to the power ln cosine x. Y prime will be this times this, which is this one. Cotan times ln cosine, okay, minus tan times ln sine. Correct. And now I need to find it at e. Okay. Take ln. I have ln y equal ln x, ln of ln x. Okay. Differentiate y prime over y will be ln x over x plus what? Here I have what? Ln x times. Here I have over ln x, and this is 1 over x. Okay. Now, y at a. Y at a will be what? Ln a to the power ln a. 1 to the power 1, which is 1. So y prime at a equals. Here I mean y prime. Yeah, here. Yeah, you can write it. Okay. That will be y at a, which is 1 ln of ln a over a. This is cancelled plus 1 over a. Ln a is 1. Ln 1 is 0. So the answer is 1 over a. That will be the answer. Y equal x to the power xy. A little bit complicated. Let us take ln. I have ln y equal xy ln x. Aha. Now I need the implicit differentiation. Yeah. Ln x to the power xy, so I have xy ln x. Differentiate y prime over y. Here I have what? I can write it x ln x times y. So it's a product of two functions now. So derivative of this, which is a little bit lengthy, ln x plus 1 times y plus x ln x, derivative of y, which is y prime. Now we need to solve for y. Oh, okay. Now it becomes a little bit complicated. Okay. So y prime will be what? Y square 1 plus ln x. I multiply by y, huh? Plus x y ln x times y prime. So take y prime to this side. So I have y prime 1 minus xy ln x equal the rest, which is y square 1 plus ln x. So it will be y prime. It will be y square 1 plus ln x over 1 minus xy ln x, which is this one. Calculation. Yeah. Take ln. I have what? Yeah, take ln here. Take ln. I have y ln x, ln of e, gone x minus y. Now I need the implicit differentiation. The product of two functions. So I have y prime ln x, here differentiate with respect to x. Y prime ln x plus y over x equal 1 minus y prime. Solve for y. So I take this to the other side. So I have y prime. I have ln x plus 1 equals 1 minus y over x, which is x minus y over x. Okay. So y prime will be x minus y over x 1 plus ln x plus 1 over 1 plus ln x. So that will be the answer. Consider the equation. The rate of change of y with respect to x at this. What they want. Y prime at 1 equals what? So take ln. I have y ln x equal x ln y. Differentiate with respect to x. Yeah. You have what? Y prime ln x plus y over x equal x over, no, equal ln y plus x times y prime over y. Okay. The point is I have x equal 1, y equal 1. So substitute x equal 1 and y equal 1 to get what? Ln 1 is 0. This is 0 plus 1. Ln 1 is 0 plus y prime. So y prime equals 1. That's the answer. Yeah. You want the equation with the tangent line. Equation with tangent line. So you take ln. I need the slope, which is y prime at x equals 0. That's the slope. Okay, so I have ln y equal x plus 1 ln 1 plus sine 4x. Differentiate with respect to x. I have y prime over y. This is 1. Here I have product rule plus x plus 1 times. This is sine 1 plus sine 4x. This one will be cosine 4x times 4. Now, if x equals 0, y will be what? 1 sine 0 is 1, so we have 1 to the power 1, which is 1. So y prime at 0, which is the tangent line, the slope of the tangent, will be what? Y at 1, which is 1, ln 1 plus 0, which is ln 1, that will be 0. Here I have 1 times cosine 0 is 1 times 4 over 1 plus 0. So the answer is 4. So it is the equation. Y minus 1 equal 4, x minus 1. No, sorry. The point is what? 0 and 1. Okay, so this is 1, but this is 0. So y minus 1 equal 4x. So y equal 1 plus 4x, which is this one. Okay, the slope of the line tangent to this curve at this point. I need what? Y prime at minus 1. That will be the slope of the tangent. Okay, so take len. To do that, you take len, be careful. I have x plus 1, len 1 plus 2 to the power x. Differentiate y prime over y. This is 1, len to the power 2x plus product of two functions, x plus 1. I have 1 plus 2 to the power 2x, and this is 2 to the power x len 2. Okay, I have the point. So substitute x equal minus 1, y equal 1 to get what? Y prime. This is 1. Len 1 plus 2 is minus 1. Okay. Plus, this is minus 1. Yeah. This is minus 1 plus 1. That will be 0. 2 is minus 1, then 2 over 1 plus 2. So this one will be len. This is 1 plus half, then 3 over 2. This is half, huh? So this is 1 plus half, which is 3 over 2, plus 0, which is len 3 over 2. That will be the answer. Yeah. The equation of this curve at this point. You want the equation. So I need first to find the slope, which is y prime at e. Take len y, x, len x. Differentiate y prime over y. That will be len of len x plus x times. Be careful here. This is over len x, and this is 1 over x. Yeah, y at e will be len e, which is 1 to the power e, which is 1. So y prime at e with the slope of the tangent. That will be y at e, which is 1. Len e is 1, len 1 is 0. Plus x is e. This is cancelled. X with 1 over x cancelled. So I have 1 over 1. So the slope is 1. What will be the equation? Don't forget the point is e and 1. So the equation y minus 1 equal 1 x minus e. So that equal x minus e. Make it in one side. So I have y minus x plus e minus 1 equals 0. And that will be the answer. Yeah. Tangent line. He wants the tangent line for this curve at this point. Slope is y prime at pi over 2. Okay. So take len. I have len y equal x squared len sine x. Y prime over y. Differentiate with respect to x. I have 2x. Product of two functions. Plus x squared times cosine x over sine x. Yeah. Y at pi over 2. That will be sine 1, sine pi over 2, which is 1 to the power pi over 2 squared. 1 to the power anything is 1. So y prime at pi over 2, which is the slope of the tangent. Slope of the tangent will be equal to what? Y, which is 1 times. Yes, here I have what? 2, that will be pi, len, sine pi over 2, which is 1, that will be 0, plus pi square over 4, cosine pi over 2, which is 0, over 1. So it will be 0 plus 0, that will be 0. So the equation will be horizontal tangent. Y, what is y minus 1 equals 0, x minus pi over 2. That implies y minus 1 equals 0. So y equals 1, which is this one. Okay. Which of the following are equation horizontal tangent line for this function? So I need to find the derivative, make it equal to 0. Okay. Take ln y. To find the derivative, I need to find the ln. I have ln y equal ln x. Differentiate with respect to x. Y prime. I need to find y prime. No? Y prime over y equals derivative of two functions. I have ln x over x plus ln x over x, which is 2 ln x over x. So y prime will be y times 2 ln x over x, which is what? Which is y, which is x, then x times 2, then x over x. I want this to be equal to 0. I want this to be equal to 0. Is equal to 0. Now this x should be greater than 0. Yeah, because the lane cannot be defined unless x greater than 0. So I have what? Very clear. I have ln x equals 0. Okay. Or x equals 0. X cannot be 0, because it's greater than 0 for ln x to be defined. So that means x equals 1. I want the horizontal tangent, which is y equal a number. So I want this number. If x equal 1, y will be what? 1 to the power ln 1, which is 1. So the equation y equal 1. That will be the equation. Because it's tangent line. No? Horizontal tangent. Horizontal means it should be y equal. So this is for sure wrong. Yeah. Last one, I think. Yes. I cannot take ln now. Because what to do this? There is no ln of the sum. We don't have any formula for that. The trick is what? You consider this y equal y1 plus y2. So it will be y prime, y1 prime plus y2 prime. I consider two functions. For y1, which is x to the power cosine x, I can take ln. So I have ln y1 equal cosine x ln x. And do the derivative. So I have y1 prime over y1 equal what? Minus sine x then x, yeah, plus cosine x over x. Okay. So for y1, what is y1 at pi over 2? It will be pi over 2 to the power cosine pi over 2, which is 0. So it will be 1. So y1 prime at pi over 2 will be what? Minus sine pi over 2 ln pi over 2 plus cosine pi over 2 over pi over 2. This is 0. Sine pi over 2 is 1. So it will be minus ln pi over 2. Minus ln pi over 2, which is minus ln pi minus ln 2, which is ln 2 minus ln pi. This is y1 prime at pi over 2. So we get this. Now we need to find this one. For y2, easier, x to the power minus 1. What is y2 prime? Minus x is minus 2. I need to find y2 prime at pi over 2. So that will be minus pi over 2 to the power minus 2. In other words, minus 4 over pi square. So y prime at pi over 2 will be y1 prime at pi over 2, which is ln 2 minus ln pi, plus y2 prime at pi over 2, which is minus 4 over pi square. And that is will be my answer. Yeah, I think we covered a good number of questions about functions and the power of functions. So let me stop the recording. Yeah. Thank you.